years, and I've been running infrastructure for AWS for the last 5. And I want to talk to you today about some of the things that we do to build out our capacity and the innovation that we do behind the scenes. Jeff Bezos has said that it's day one, and in our space, it really is day one. The other thing that I really like about Amazon is our focus on the customer. And as that is a true north, we've actually built some amazing things. So I want to start with that. First, our customers expect to have a single instance of compute, a gigabit of capacity, or some database capacity. And they expect that to be there whenever they need it. And so long as they can think as long as they don't have to think about this, they can focus on the services and applications that differentiate their business, and not the undifferentiated heavy lifting that my team does for them. This is the foundation of what we build, and I think about this a lot like I think about a power outlet. Now, imagine what it would be like if, when you went to get power from an outlet, you plugged something in, it wasn't there. You expect power to be there, and not occasionally that it's not there. Our customers expect the capacity to be there every time, even when they need more than they thought they'd need. Just like when you're in your house, you'll expect that a power outlet's going to work, whether you've had one device plugged into it or multiple devices. Now, this brings us to some core aspects of capacity that we hold as tenets, as things that must be done. The first is that the capacity's just got to be there every time around the world, just like the power outlets in your house. Next, it needs to be reliable. And not just reliable, but highly reliable. The sort of reliability that you expect from, say, large power companies serving metropolitan areas or hospitals. It's got to have the aspect of reliability of it just can't fail. And it's also got to be low cost. It has to be affordable from the smallest businesses to the largest enterprises. And it needs to be that way the world over. It's one of the things of cloud computing that customers have just come to expect, and so that's got to be there. Now, that sweet spot in the middle, where these Venn diagrams overlap, that spot between low cost, reliability, and on-demand capacity is the thing that my team focuses on delivering time and time again, every single time somebody asks for it, every single day. And this has to be done at a massive scale. So let's talk about what sort of massive scale we're talking about. We have to support all of the services and features that AWS launches every year. In 2008, we launched 24, and in last year, we lost more than 500, and we're well above that this year. What's more, every one of those services has lots of customers, an enormous amount, over 1 million to be in fact. And if you look at this graph, what you'll see is that the slope is increasing, and we're accelerating. Every one of these customers expects that we'll have low-cost, reliable, on-demand capacity delivered flawlessly every single time. And frankly, we expect nothing less from ourselves. So it turns out that scale lets us do some pretty interesting things, from building our own networks and building our own servers to building our own data centers, from the largest 200,000 plus square foot facilities down to the smallest components on server and networking gear. This ability to customize enables us to remove a lot of excess features. It allows us to simplify the design both from a reliability perspective as well as an operational perspective. This in turn lets us work with OEMs and component manufacturers to ensure that our capacity is always there, that hard disks, memory DIMMs, racks, servers, networking gears, in fact even transformers are forecasted and stocked and ready for on-demand. Less complexity in the gear means that there's less things to break. This also gives us a deeper understanding of all these components, which enables us to deliver more automation, meaning less human intervention, meaning less human error, also leading to higher reliability. Higher reliability plus less complexity, more automation, and direct access to these various component manufacturers means lower costs. Now, this allows us to lower prices for our customers. It allows us to add more innovation to our systems. This helps us to get more capacity, which leads to more customers, which is this sort of virtuous cycle that just feeds on itself. And each of these things build on each other. Each one of these cycles adds extra value to us. It's a virtuous cycle, and we like virtuous cycles at Amazon. Virtuous cycles are things that are self-sustaining and continue to add value both for us and our customers. Now, in a moment, I'm going to give you some details about how we actually do this. But before I do that, I want to take a step back and talk about a job I had about 8 years ago. I used to run the data centers in 2006 for a Fortune 500 company. And in that Fortune 500 company, our server utilization was roughly 11 to 15%. Now, that 11–15%, we understood, wasn't where we needed it to be. And so we worked very hard over several years, working the container technology at the time in Solaris, and we were able to get to 19% utilization. We were pretty happy with that. It was a big deal. But it turns out that 19% utilization means that 81% of the capacity was idle. Now, that was a combination of not being able to get access to the rest of the CPU, as well as just having extra capacity necessary for those spikes, for capacity that we might need at some other point in time. This all made compute and storage pretty expensive. Now, because the utilization was low and the cost of the equipment was high, we didn't really experiment all that much. Experimentation means that you don't really know if the application is going to do what you need it to do, whether it's going to differentiate for your business or business partners. And so instead, we would spend time making sure that the application did what we needed it to do. Now, that meant that we had lots of meetings. We met with the finance team, we met with our business partners, we met with the leadership team, and ultimately, if we got ourselves comfortable that this application was worth pursuing, then we'd look and see whether there was data center space and networking available. If there was, we'd collectively argue about whether or not that data center space would be reserved for this application. And if there wasn't, we'd argue about whether or not we were going to go build this extra data center or networking space. What's more, the data center and networking space was also underutilized and expensive. So you can imagine the amount of time it took once we got past all of that required us to decide we would order the compute, we'd order the networking gear, we'd order the servers, whatever it was that it took, and it would take 3 to 9 months before we could deliver this capacity to the developer. Now, not a lot of experiments got past this stage, but when they did, we were using pretty high-end servers. And so at one level, we were kind of happy with the reliability. The problem was that this had unnecessary features, and it was missing things that we wanted. Also, that added complexity led to operational issues, which sometimes resulted in outages. On top of that, it was a poorly utilized system, as we already, even at 19%, and the capacity would take months to deliver, on average of more than 6 months. So this led to a vicious cycle where this added complexity led to lower utilization or lower reliability, lower utilization. Also, the developer could get the access to the capacity in 3 to 9 months. So the end result of this vicious cycle, a lot of wasted money, a lot of wasted time, and some frustrated developers who really just wanted to be able to grab whatever that capacity was and go. So we just didn't have the scale in my previous company to break this vicious cycle. So how does scale change things? First, let's go back to that basic unit of capacity. We first start thinking about the data centers when you start thinking about delivering capacity, because it takes the longest to build, and we have to think most about how much we're going to need the farthest in advance. Step one on this, we've got to get some land. That land needs to be buildable, stable, not in a floodplain. It's got to be permittable and at the right cost. And then once we had found the land that we want, we've got to either buy it or lease it, and in some parts of the world where that's not allowed, establish complex legal arrangements so that we can either manage it ourselves or work with a partner who helps us. Now, this land, which will house a lot of data centers, is going to need to have power. Now, the data centers are pretty efficient, and I'm pretty happy about that, but even so, we'll need a lot of power. For instance, in Oregon, we built our data centers near this dam so we could get an enormous amount of hydropower. Now, to give you an idea about why we need this much power, I want to talk about the key components that we use at scale. When you think about a breaker, you might think about something like this. This is that sort of switch that sits behind a panel in the end of a hallway somewhere that lets you turn on or off the power in your house so you can work on the electricity. When we think of a breaker, we think of this. This has three-phase power coming into one set of those towers and coming out the other side, so primary to backup. This switching gear has Tesla-like coils to prevent arcing from occurring because of the massive amount of energy that goes through these when we do the switch. When you think of a transformer, you might think of this, which is a typical sort of transformer you'd see in a household appliance, maybe even a laptop. When we think of transformers, we think of these and these at our data centers, which we need to deliver power and over for the hundreds of megawatts that we deliver globally. Now, in the past, we purchased power directly from power companies. Now, it turns out when you're buying power from power companies, you get the price and renewable mix that's available. But at a certain scale, you're not as constrained, and there are a lot of opportunities that open up. So one of those opportunities, we started working with power generation companies directly in the form of power purchase agreements, or PPAs. And these PPAs, we did 3 of them last year, and these 3 PPAs are helping us to meet our commitment to renewable energy. The first of these we signed in January, which is a power purchase agreement with Pattern Development for a 150 megawatt wind farm. We call this Amazon Wind Farm Fowler Ridge, but I want to point out something to you. Take a look at these towers. Now, these towers are hundreds of feet tall, and I want you to take a look at one of those blades. In this picture, it doesn't look all that big, but in fact, that is one of these blades. These blades are enormous. We also, in June, followed with an agreement to Community Energy for an 80 megawatt solar farm. This 80 megawatt solar farm is the largest solar farm in Virginia. And we followed in July with the Amazon Wind Farm US East in North Carolina with Iberdrola for 208 megawatts. This is also, we believe, the largest wind farm, utility-scale wind farm in North Carolina. Now, we're proud of these deals. 3 of our 11 regions are carbon neutral: US West, GovCloud, and Frankfurt. Overall, we've committed to 100% renewable energy, with an interim milestone of 40% at the end of year 2016. I want to point out, though, this is on a large and very rapidly expanding base. Think back to that line with the customers. So 40% this year is not 40% next year, and it turns out to be a pretty aggressive goal. We've also hit some major milestones this year. In 2015, we're achieving a 25% renewable energy mix. We've recently done a pilot with Tesla using batteries to improve the reliability of our data centers. We joined the American Council of Renewable Energy, and we're participating in the U.S. Partnership on Renewable Energy Finance to find and enable more options for renewable energy. So, back. So I want to talk to you a little bit about what the efficiency of this renewable energy provides for us and the efficiency of our power in general. First, I want to give you a couple interesting facts. The average AWS customer versus using standard or average enterprise data centers uses 77% fewer servers and 84% less power. Now, for details on how this is calculated, there is a blog on our sustainability page by Jeff Barr, and I suggest that you read it. It's called Cloud Computing Server Utilization in the Environment. I'm going to walk you through how we got to these numbers. But before I do that, I also want to take a step back to that previous role that I had in the data centers. Now, our utilization, we were kind of average, and that utilization was sort of on the lower side, but there's good reason for that. I mentioned the fact that you can't always access all of the CPU. It's hard to get the sort of sharing that when you're running the applications on your own. But what's more, in many cases, you're buying enough capacity to handle peak loads. So if you're in a retail business, you're buying enough capacity to deal with the end of the Christmas season. Or if you're running financial applications, you're building enough capacity to deal with quarter close. And then the rest of the time, that capacity is sitting idle. In the 2014 Data Center Efficiency Assessment from the National Resource Defense Council, they found that the average cloud computing company was operating at 65%. This is their estimate, and that's the one that we'll use for this discussion. What they also found in that same survey was that the average enterprise data center were operating between 12 and 18%, which turns out to mirror pretty closely the experience that I had when I ran the data centers in my previous company. So we're going to split the difference and call it 15%. Now, that means that when a customer moves from the average enterprise data center to the cloud, you use 23% of the servers and the associated power to do the exact same job. Now, in the annual Uptime Institute survey, they took a look at power PUE, power usage effectiveness. Now, it turns out from us, this gets even better because we spend a lot of time engineering our PUE to be as close to one as possible. Now, I'll spend a second and talk about PUE. If you're not familiar with it, PUE is that measure of the amount of energy that is required to pull from the grid to support your critical compute. So the closer to one you get, the better. If you have a 1 PUE, it means that for every unit of power required to support your critical resources, you're taking 1 from the grid. Whereas if you had a 1.9, that meant that 1.9 units of power were pulled to support 1 unit of critical compute. Now, that 0.9, you might wonder where it goes. Turns out it's used by chillers, air handlers, or is simply wasted in the distribution process. So again, the closer to 1 you get, the better you are. This institute, the Uptime Institute, found that the average enterprise data center ran at a PUE of 1.7. Now, 1.7 is not all that bad for an enterprise data center, but it turns out to be not so good when you compare it to what they found for cloud data centers. And in the cloud data centers, they found a 1.07 to 1.15 PUE. Now, to simplify this calculation and to be a little conservative, I'm going to use 1.2 for this illustration. With 1.2, you use 71% of the power from the grid on the cloud than you would from an enterprise data center. That's a 29% reduction in power that you need from the grid. Now, if you combine these two things together, you get some pretty compelling numbers. By having a quarter of the power, a quarter of the servers, and then those servers, because of the PUE, use 71% less, that gets you to 16% of the power needed to support a workload in the cloud that you need when you're running in an average enterprise data center. That is an 84% reduction in power. What's more, as I've mentioned, our renewable energy is going up. So of the energy that's left, more and more of that's becoming renewable. Now, you might say, hey, that's great. Amazon is conscious of the environment, and you wouldn't be wrong. But it gets even better because the work that we're doing with the PPAs, with power efficiency, with working with the government and the utilities to figure out cheaper ways to deliver this renewable power means that we're delivering it at a reduced cost. It's one of the things that I love about working at Amazon. We get to take on really hard problems that most folks can't and deliver efficient, cost-effective solutions. I challenged my team several years ago to come back with solutions that enabled us to get renewable power at or lower than the cost you could get on the grid, and they did it. So let's talk about how this impacts our customers. I'm going to use one customer in particular. Netflix decided early on to go all in on AWS. They wanted to focus on delivering the best streaming service they could and not worry about managing the infrastructure underneath it. And what's more, they're pretty concerned about efficiency and energy utilization. So in 2014, they found some really interesting stats that I want to share with you. First, because they've chosen to run their services in our most renewable regions, they've got their renewable footprint up to 50%. And what they haven't covered with that 50%, they've bought in RECs or renewable energy credits to cover the rest. That's pretty impressive. Their server utilization is greater than 50%. They've continued to focus on ways to improve the utilization on top of using AWS, and that's led to an 85% reduction in server costs, which also is a massive reduction in their carbon footprint, which you can find on their blogs. So let's get back to the data centers. We've talked about land and getting power and the benefits of the types of power that we're getting, as well as the efficiency for our customers. I'm just going to talk to you now about what it takes to actually build out what we do. So the first step is contracting with architects, engineers, or general contractors when we don't have them available on staff. Next, we have civil site work that needs to be done. That civil site work includes surveys, soil samples, environmental studies, and roadways, as well as drainage. Next, we go into the planning process, the building itself and the electrical design, as well as the permitting process and whatever local governments we have to work with. Now, it turns out this takes a lot of time. It's something that we've done over and over and over and have gotten it better and better at it, shortening the amount of time that it takes. At this point in the process, there's one important thing that we need to talk about, and that's security. After the building is completed, but before a single piece of equipment, servers or networking gear, rolls into this facility, it needs to be physically secure. Our strategy is a 3-layer defense. We have 3 layers that are required, and I'll go through each of these. The first one is a fence. And in fact, in some places, they are crash-rated fences where a vehicle cannot break through them. And in other places, they're not crash-rated, but they're backed by jersey barriers like you might see on a freeway or on a construction site. Many of our sites have internal trip light perimeters that set off alarms, and each are managed and monitored 24/7 by a security force. Now, once you get past that first perimeter, our next perimeter is at the building. And that building requires a badge swipe, dual authenticated badge swipe, where you have to have the right badge and a personalized PIN in order to get into it. Now, the building houses all of our critical equipment and things like chillers, switchboards, and in some cases, generators. The only people who have access to these rooms are the engineers who need to work on it. Each of these, the doors to this building has a video camera, and each of those video cameras is monitored by a local facility. There are guards in the local area that monitor it, as well as a remote facility that also monitor it. And at the slightest indication of an issue, a guard's dispatched. Now that gets to the final area of our security strategy, and that's our data halls, where the servers and networking gear resides. These rooms are also dual authenticated badges, so swipe plus a PIN. But to even get to that door, you need to have gone through the first perimeter, and then the building perimeter. And then when you do get to this door, it also has a video camera, as well as a metal detector managed 24/7. So all of this needs to be in place before the first server or networking gear rolls into the data center. Now, while we're on the subject, I think it's worth mentioning how we manage customer media, the places that store customer data. As I mentioned on the previous slide, every single one of our data halls has a metal detector. So once something goes into a data hall, it doesn't come out without setting off the alarm and having the guard stop and make sure that the disk is managed properly, which I'll talk about in a second. Before any of these disks are put into production, they are alarmed, serialized, monitored, and tracked. Now, when we do decide that we want to retire a hard drive for some reason, it's broken. First it gets degaussed, and then it gets shredded. And what comes out are these little bits. Now, this may be something that is unique to AWS. Every single disk that comes into the data center is monitored and surveyed 24/7. And even if it breaks and needs to come out, we don't return disks for warranty like some data centers might. The only way that a data center leaves, or the only way a disk leaves our data center is if it's confetti. This is not a place where we cut costs. Ensuring that our customers' data is secure is our #1 priority. Now that we have a secure data center, we can start to bring the network in. Now, the thing about our networks is we used to build our networks using the standard networking gear from the standard vendors and OEMs. What we found, though, is that that gear was built for old world environments and wasn't meeting our needs at scale. These boxes were built with features that we didn't want or need for use cases that we simply didn't have. That added complexity meant lower reliability. And then when we had issues, it may or may not be a priority for the OEM to fix. So we decided to start working on something different. These networks simply weren't built to handle the sort of scale at the continuous growth and the capacity that we needed. So in 2011, we started building our own networks. Now, what we like about this is it allowed us to simplify the design and build the features that we wanted. Features like traffic engineering, automated provisioning, optimization. It also allowed us to cut things that we didn't like, leaving room for better processes around issue remediation and change management. It also lets us run on simpler hardware, which allowed us to take little costs out of every networking device. And it turns out, at our scale, with the amount of networking equipment that we buy, those little cost changes added up quickly. So now we have a data center that's got a network in it. And I've got AZ up here because AZs are the availability zones that we make available to our customers that they can see. But each of these AZs could be one data center. It could be many data centers. It just depends on the size of the region. Now, each of these, if you've ever built out a network in one of these, you'll know that it's no small feat. But then the next step is, how do you connect all these together? So each data center or AZ needs to be connected to every other one. And we do this because there's always a chance of a fiber cut. And these fiber cuts, as rare as they are usually someone with a backhoe digging someplace that they shouldn't be. And when they do, it takes time for us to figure out where the breaks occurred. And once they've found the spot where the breaks occurred, you have to splice together the fibers one at a time. And if you've ever seen one of these devices, they can be a couple inches across with hundreds of fibers inside of them. Each needs to be spliced back together. So in order to maintain continuous operations, we have 2 fiber paths coming out of every one of our AZs and data centers. Each of these are physically separated so they can't be trenched across with the same backhoe. Now these fiber paths can be miles long, and so often because we're building our own data centers, we don't have the access to the fiber that we want. So if it is available, we'll lease or buy it. If it's not available, then we trench it ourselves. And once we've trenched it ourselves, we put our own networking gear on both sides of it because we like to manage it. So in the odd chance there is a fiber cut, we can manage the traffic around it and maintain continuous operations. With the 11 regions that we have running right now, we have hundreds of miles of metro fiber that we manage that has to sustain 25 plus terabytes of inter-AZ peak capacity. Now, the next step is, how do you get it to the internet? We get this to the internet through transit centers. Now, we have 2 transit centers, and each of these are completely separate so that if one fails, that the other can pick up the load. Also, you'll notice that each of these transit centers needs to be connected to every availability zone or data center. And similarly, because we're often growing so quickly, we'll need to either lease or buy that or trench it ourselves if it's not there. These are also managed on either side with our own networking equipment. Now, once we've got this connected to the internet, we need to think about the internet itself. I mean, it turns out the internet's a pretty important part of the service we provide. And so understanding how the internet operates and ways to make it better become an important part of what we do. The internet is a collection of providers. Some are fantastic, some not so much. Some have lots of capacity, some don't. So we decided that we needed to build a solution that enabled us to improve the performance of the internet where we could. And we started building long-haul routes that we call our backbone. So in 2013, we started building out our own backbone. Now this backbone connects every other AZ to each other and allows us to provide optimal routes for traffic that's coming in and out of those data centers or going to, either going to peering points to get to the general internet or to other data centers. Now these long haul lines give us more control because we manage the capacity and monitor every aspect of it. If it turns out that the fastest and most effective route for traffic is through the internet, it'll automatically go through the internet, or it can use our long-haul lines. So we believe that this improves performance and reduces jitter. So now that we've got data centers connected together and connected to the internet, let's talk about servers. Servers come in next. Problem with servers is we thought about those a lot like our old servers, or a lot like networking. These servers were built by OEMs, and these OEMs managed the software and the hardware. The software and the hardware potentially had features that we wanted or didn't want, and it had features that we didn't need. If there were issues, just like the networking gear, it may or may not be a priority. So in 2012, we started designing and building our own servers. Now, what we like about these is that we ensure that the servers have only the hardware on it that the service needs. The service may need more memory, it may need more hard disk, and that leaves little of the available hardware on the box unutilized. What's more is the services themselves are optimized for those servers and drives the unit cost even lower. Now, additionally, what this did is it led us to start working more closely with ODMs and manufacturers. And once we started working with the manufacturers, we started getting a better understanding of our supply chain. Now, it turns out that we want to have a deep understanding of our supply chain. And when I say a deep understanding, I mean that we have control and understanding of where every aspect of the components that we need to deliver our capacity is. And our wake-up call came in 2011. Those Thailand floods in 2011, which impacted the hard disk manufacturer industry. Most of the world's hard disks were built in Thailand at the time. And when one flood hit most of those manufacturers and you don't have a direct relationship with them, it turns out to be pretty hard to get the stuff that you need. Now, if you're not familiar, well, at first, when we started working with our OEMs and we were working with an OEM, and the OEM was going to be delivering this capacity for us, and they were managing our supply chain. We didn't have visibility into that, and we asked for disks, and they said there's none to be had. Now, they could give us some, but they couldn't meet our capacity needs. So we got on a plane and started visiting these hard disk manufacturers ourselves. And that's when we found out how bad this problem really was. Turns out that in Thailand, in that area around Bangkok and north, most of the hard disk manufacturing is in a single plane. Now, the problem with the floods was that that plane and everything around it was severely impacted. And when I say severely impacted, these facilities were underwater. And I'm not talking about a few inches of water. I'm talking about 6 or 8 feet of water. The problem gets a little worse than that, because the problem that we experienced was that 50% of or 60% of the world's hard drives were coming from Thailand. 50% of the assembly was done in Thailand. But it turns out that just about everybody counted on parts from Thailand, from casings to rockers and other critical parts. So even if a facility was not hit by the flood, they were impacted by it. And this impact led to supply or manufacturing lines completely stopping or being in severe short supply. An example of that, when we did this tour, we found that the motor that spins the platters on a hard disk were manufactured, 85% of the world's supply came from a single vendor, and that vendor was in this floodplain. Now, luckily for us, when we did this tour with our hard drive manufacturers, there were a few that understood where cloud computing was going. And remember, this was 2011. We still have great relationships with those vendors today. And I think back on that, our volume wasn't all that much. What we were asking for wasn't a big deal. In today's world, it simply wouldn't be possible without a direct relationship where we're working with these vendors and managing our supply. So we were able to get the disks that we needed because we had these relationships we established on the spot. But the real lesson that we learned was that disasters happen and you need to be in control of your supply chain. So we've turned our supply chain from potential liability into a strategic advantage. Now, one of the ways we did this is we started working closer with our retail counterparts. There's really not a better organization in the world for getting parts from warehouses to consumers. The Amazon fulfillment centers are world famous for their ability to deliver packages in days or hours. So we spent time with them and learned about how we could modify our processes and build them into our workflows. Now, I'm not going to share what those things are because they're proprietary, but I will tell you that these have turned out to be some of the more important things that we do to ensure that we can deliver capacity on demand. So let's talk about how all of these things come together as a region. Now, in regions, we have new regions. We expand existing regions. We add new AZs. We expand AZs. And for every one of these, we do all the things that I've talked about: acquiring land, pouring concrete, installing networking, trenching fiber, installing servers. And we do this every single day in IAD, in Dublin, in San Francisco, in Singapore, in Tokyo, in Brazil, in Portland, in GovCloud, in Sydney, in Beijing, and in Frankfurt. Next year, we're adding 2 more regions. In Q2, we'll be adding a region in India. And in Q3, we'll be adding a region in Ohio. I didn't expect that. And on top of these 11 regions, there are over 50 CloudFront POPs. So every region and every day, we deliver land, figure out ways to get creative power to our sites through complex, large distribution equipment. We do construction and planning with local governments. We build security and manage and monitor 24/7. We deliver networks. We trench fiber. We use our complicated supply chain to deliver servers so that we can deliver reliable and low-cost capacity when you need it. So I'd like to conclude with a few parting thoughts. Scale's changed the game for us. It's allowed us to do things that in my previous job I'd like to have done, but couldn't. We're doing innovation in areas that's exciting for me and my team, and it really is day one. We really have just scratched the surface, and there's a lot of exciting things we're looking forward to doing in the next few years. With that, I'd like to thank you for your time.